we're going to talk more about the photoresistor. So basically, photoresistor or the light dependent resistor, or sometimes we abbreviate it as LDR. So it's a photoconductor. So technically we call this also, or the function of this is a special resistor made of a semiconductor material such as a cadmium sulfide or a cadmium selenide. So its working principle is based on the internal photoelectric effect. So the stronger the light, so basically the lower the resistance value. So that's why it gets the LED gets brighter. Okay. So what we're going to do right now is I'm going to show you how you will be able to simulate a photoresistor using Arduino at the same time other components in our TinkerCad. So let's start. So let's drag first our resistor. Okay. So the resistor that we're going to use today do have, or we need two. Okay, for resistor. The first resistor value is 4.70 k ohms. Okay, again for 4.70 k ohms. So the other one is an ohm, which is 250. Okay, so 250 ohm. So that is the resistor value. Okay, so let's start creating and adding other components. So the LED light bulb will be here, and look for the photoresistor. There you go. So those are the small components, and then we're going to add the following. So breadboard small and the Arduino Uno microcontroller. Now select again Arduino Uno and then click rotate to make it 90 degrees. Okay. Next, we're going to attach the small components in our TinkerCAD or into our breadboard. So basically, we're going to add it here in group A, B, C, D, E, and same goes with the photoresistor. Now, anode and cathode are parts of the LED. Okay, so basically anode is the positive, cathode is the negative. However, in the photoresistor, we're just only using a terminal 1 and terminal 2. Okay, so what we're going to do next is we're going to attach the resistors. The first resistor will be in the same group as the cathode. However, like what we did on our previous project, so it should be aligned also in the cathode area. Make sure that the terminal 1 is connected to the negative port bay area. Next is, we're going to add the 4.70 or 4.7 k ohms, same group as the terminal 1, and the same part, or technically same port. The terminal 1 of the 4.70 k ohm resistor is also the same group as the negative port bay area. Okay, so now, since we already attached our components, we're going to create our wiring. So let's start with the negative port bay area. So let's color this black. Okay, so this black wiring will go to the GND of the Arduino. Once attached, okay, we're going to create our connection from the anode group going to any digital port here. This time, I'm not going to use digital port 13. So I'll show you that in any connection, you can create your technically your digital pin, or you can connect any of the digital pin. So this one, I will attach it here in digital port 9. Okay, so there you go. Next, so since we already added it into digital port 9, we're going to create a wiring coming from our photoresistor group. So right above the resistor, okay, with a 4.7, so right in between terminal 1 and terminal 2 pins of the photoresistor and the resistor itself, we're going to create a wiring going to A0 so that we can determine that it is also an analog device or component. So let's create an A0 here, and then let's change the wiring color. There you go. And for our last wire. Terminal 2, we're going to create a wire going to the 5 volts of Arduino. So here, there you go. Then to change the color blue. Okay, so this is the wiring for our photoresistor. Now let's start creating our program. The program is very simple. The program basically do have the same content, actually very different in a way, but the sensor value will be the same as the resistor, or what we call the potentiometer program. So let's go to text, click here, and then let's remove this. So let's have our global declarations first. So let's have int sensor value is equivalent to 0, semicolon, and then int L1, this time it is equivalent to 9. Okay, now let's have our void setup. So void setup, open close parenthesis, opening curly braces, wherein we have pin mode, okay, A0, comma, input, okay, input, comma, or semicolon, and then pin mode, opening L1, comma, output, semicolon, and then closing curly braces. Now we're going to start with our program. So void loop, opening, closing parenthesis, opening curly braces. We're going to add here our sensor value, which means our sensor value will be connected to the sensor value, or basically to the analog feed or to the analog pin, wherein we're going to declare here analog read A0, semicolon. Now we will have or let's say those, and since it is a photoresistor, and the photoresistors varies to or technically it depends on the light on the surroundings. What we're going to do here is we're going to create parameters. Now those parameters will be under the analog right. So basically we are teaching the analog a certain program so that it can functions very well. So L1, so basically the light bulb or the LED, then there will be the map. The map will be the one who will handle the parameters. So the sensor value, which means it is equivalent to 0, then comma, 0, which means technically no value, 1, 0, 23, which will be the maximum parameter for Y, and then let's add again for X1 parameter 0 or value 0, and 255 the maximum parameter for Y. So basically we do have the parameters for the LED, or the value for the LED itself. So don't forget to close the parenthesis and add semicolon. Let's have a delay here so that it will be stable in our program. Then semicolon. So add curly braces here. Okay, so we have an error here because of the misspelling of the sensor. Okay, so let's remove R here, and then let's start again the simulation. So notice there is no already error, so that is a quick tip for everybody. So please also take note of the spelling. Now, for us to be able to know if our LDR or our photoresistor works, so select the photoresistor and then change the brightness. Okay, so the higher technically the light, which means the higher also the value of the resistor. Okay, so mas lower value to, mawawala yung power ng resistor because it will become, or the LED will become brighter. Okay, so that's it for our photoresistor.